one of the latest, most outstanding, and advanced physicists, has expressed his opinion on the matter. Michio Kaku, known for his fantastic contributions to the fields of physics, has confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists thought could not exist. These investigations have the potential to open new dimensions in our scientific understanding of the universe. It is therefore exciting and worth keeping an eye on these developments. Michio Kaku is an incredible figure in the scientific field. A physicist of American and Japanese origin, he is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the extraordinary results of the James Webb Space Telescope project. We are delighted that this outstanding scientist has decided to break his silence and publicly share what can no longer be denied. The passion and almost astonishment of the renowned stellar physicist are evident in his comments on the discovery made by the James Webb Space Telescope, expressing that this has been the highlight that has piqued his interest. Join us to explore the implications of Kaku's discovery of these 6 massive galaxies. Michio Kaku is a scientist who has always been willing to consider new theories throughout his life. He is aware that Einstein's equations of relativity and Newton's laws are inadequate to capture the full complexity of the universe. Kaku understands that the discoveries of the new telescope have the potential to enrich the scientific field. Even though many of his colleagues have not been able to adopt this view, this is generating concern and insomnia among proponents and opponents of the Big Bang and quantum mechanics. However, this only provokes laughter from Kaku. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way. Despite having formed only 200 to 700 million years after the Big Bang, the team of astronomers who made the discovery has dubbed these remarkable galaxies universe breakers, because, if confirmed, they would revolutionize our entire understanding of the universe. Something doesn't fit here anymore. The Big Bang theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for these objects to reach sufficient density and produce light. The formation of complex systems such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity suggests that they were likely forming hundreds of new stars each year. While our galaxy forms stars only sporadically, it remains uncertain exactly when the first galaxies formed. Researchers have not been able to determine this so far. The only thing that is clear is that initially there may have only been single stars or groups of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. These small galaxies encountered other galaxies and gradually grew. According to previous theories, especially organized and massive galaxies could not have existed at that point, which raises the question of whether the universe is much older than previously believed or whether complex stellar and galactic arrangements developed much earlier. This situation is difficult to accept for conservative science, which still finds trouble with this model, and some branches of physics vehemently refuse to accept this discovery and question possible errors in the age calculations. Kaku was aware of this and had this to say: "There are many examples of old and false theories that stubbornly persist due to the status of some scientists. Many of these theories were only discredited when a critical experiment revealed their falsity. Therefore, the fundamental work in any science, especially in physics, rests with the experimentalists who keep the theorists honest. In reality, on this planet, we know very little about the actual beginnings of the cosmos. The Big Bang theory was established in 1927 based on observations of the expansion of the universe. Those data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond people's imagination. Even today, scientists still face difficulties in understanding it. But it is crucial to reconsider these possibilities. These new demonstrations do not align at all with what researchers have based on the Big Bang theory for decades. However, science has proven time and again that reevaluation and openness to new ideas are integral parts of the scientific method, as is the confirmation of certain theories through observation. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe, and these unique systems occupied a defined space. However, we now know that everything in the cosmos is in motion. Planets orbit stars. Stars move within their galaxies at hundreds of kilometers per second. And entire galaxies move swiftly through the cosmos, the fate of which we cannot yet predict. Today, scientists are challenged to accept uncomfortable truths and to recognize that theories are not merely guesses, but also not absolute truths until they are rigorously tested or confirmed through accurate observations. The concept of the Big Bang arose from the observation that galaxies are moving away from each other, and this distance is proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures seemed to support this principle. However, it is vital to remember that in the past, those who believed that the Earth was flat and that the Sun revolved around us also had observational proof for their assumptions until coincidence or technological improvements provided a clearer and more accurate picture. Right now, we are witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang. But instead, they have come across these 6 galaxies that seemed impossible. This reminds us that science is constantly evolving, and that scientists must be open to new discoveries and reconsider existing theories based on the available evidence. Researchers choose redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, you can imagine standing still and seeing a car coming toward you. The car moves toward you. You hear the sound of the engine getting louder. But once the car passes you or moves away from you, the sound of the engine changes. This is because the sound of the engine varies as the car moves. The same is true of light. When a light source, such as a distant star, moves toward us, the light we perceive shifts toward bluer colors. On the other hand, when the light source moves away from us, the light shifts toward redder colors. This phenomenon is called redshift. Physicists have transformed redshift values into velocities and distances for measurement in the study of the cosmos. However, it is critical to note that small errors in these measurements could have significant consequences. The measurement techniques previously used are currently under review, and it is exciting to see what conclusions scientists will arrive at. As for the current demonstrations related to our cosmos, it is essential to consider whether they are based solely on redshift errors or whether some scientists are simply denying the facts. This is a question that requires rigorous analysis and careful review of the data and methodologies used in the studies. Thank you very much for watching the video. As always, we remind you that you can post your questions in the comments section. If you liked the video, remember to hit the like button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this. Thank you so much for watching, and see you in the next one. Music.